Hi guys. So in the continuation to the longest subarray with some k, we will be solving today the optimal solution for that optimal solution. So what is the intuition behind this? How we can derive this as a optimal solution is we need to observe certain things here in this. So we will be given 1, 2, 3, 1, 1, 1, 1. This is the So if you carefully observe, we need this subarray, there is one this subarray, and there is this subarray, right? So if you can carefully see, it is a window. This is a window. This is a window, and this is a window, right? So I just want to get this size of the window, so maximum. We are in three windows. The maximum size which we have of these three windows will be my answer. There is a simple intuition behind this problem. How we're gonna solve this? So, let me try run to you first. Then we'll come to the pseudocode or how we're going to solve. So we'll start iterating here from here. So let's keep sum as one. Let's keep it one. And this will be my window. Okay. We'll be seeing what is the logic. Like this should be equal to k, right? So we will be seeing one is equal to one is less than k and less than 3. We'll be saying no. That what does that mean is it is it requires some other elements to sum it up, and then it may end up to the sum k. So what we'll do, we will increase the window size. Now the sum is 3. The sum is equal to k, less than or equal to k. So we'll check equal to condition, and we saw okay, now the max length will be this size of this. So what is the size of this? 2. So I'll store it in the variable. Now we'll move further. So if we move further, we get the sum as 6. So sum 6 will not benefit us because it is exceeding k. We have to reduce some elements to reach less than or equal to k. What we will be doing here is we will be shrinking our window size. Okay. Here what we will do, we'll shrink till where my uh, sum becomes less than or equal to k. Okay. So here what will happen, I'll come here, I'll reduce this. Now my window will be looking like this. So 3 will be equal to 3. Okay, I saw this. And what will be the length of it? This is the window size. What is the length? Length is 1, and it is less than the maximum length we are already having. Will not replace it. Fine. Post that, what we will do, I'm just keeping it here. We'll try to increase the window size. What will happen now? Sum becomes 4. But do we need that? We don't need that. We'll keep shrinking. We will shrink our window size. Now window size is this much. In the iteration, what we will do? We'll iterate over these elements. We'll include this. It is less than, no problem for us. We'll keep increasing. Now we'll increase this window size. Now window size is this, and the sum was 1, happened 1, then 2. Now the sum is 3, which is equal to k. So we need this size of this window. So, and this is, if we compare with our maximum length, this is greater. This window size is greater. So we'll get this 3. So this is the dry run basically on the uh, sum. So let me go to the uh, code section. It is simple one. You see, we will be taking one. This is not the one. Let me go here. This is the better solution basically. Let me iterate over that. So we'll keep for window, defining a window, we'll keep one left pointer, we'll keep one right pointer. We will store the initial element as the first element of the array to capture the third 311 case. Okay, so what will happen? We'll be iterating, we'll be iterating over the elements of the array in this first loop, and in the second loop we will be checking when it should be within the uh, array bucket, and if sum is greater than, it's exceeding my limit, then what will happen? We'll reduce it, and we'll uh, reduce the window size as well as the sum. So this is that code. If it is now, if the sum is equal to k, we'll find out the length of the window. This is that one. And if it is in the boundaries, then we will keep on increasing the window size. And but we have to check if my window size is less than n. If it is, we will keep on adding the sum also in the variable. Post that, if you do that, we will be getting an answer. The time complexity of this will be big O of 2n, which is nothing but equal to big O of n. Space complexity is O of n. So you might be thinking that we are having two loops, then how it is 2n. So if you carefully observe here, we are having something called right pointer as left pointer. So this will travel one time n, right pointer. If you carefully observe, left will also travel one time only here. It will not travel multiple times. I will, if I shrink this window, left will not iterating multiple times. It will also travel one time only. If it is travel one time, it is boiling down to 2n, not n square. So I hope this part is clear of time complexity. This will be the optimal solution of that. Yeah. So if you understand, please like, share. Thanks, guys.